Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is matrices. In this video, we'll be focusing on solutions to previous year exam problems which has come in CBSE board exam. In the first problem, a shopkeeper sells 50 chemistry and 60 physics and 35 maths books in a particular day and sells another 40 chemistry, 45 physics and 50 maths book on the second day. The selling price for each subject book is given as this: 150 for chemistry, 175 for physics and 180 for maths. We need to find the total sales or the revenue in the 2 days using matrix method. Then further, if cost price of all the books together is 35,000, we need to find the profit. So we will use the matrix method. So on day 1, what is the sales? 50 chemistry, 60 physics and 35 maths. We have to write in a particular order. Day 2, we'll write in the same order as the day 1. So 40, 45 and 50. So we can compute total sales. Add these two: 50 plus 40, 90, 60 plus 40, 105, 85. Now given price as 150, 175 and 180. So we can get revenue or sales, total sales into price, that is 90, 105, 85, 150, 175, 180. We multiply these two, matrix multiplication. You know that we can easily do like this: 90 into 150 plus 105 into 175 plus 85 into 180 will give you 47,175. So this is part 1 of the problem completed. Find the total sales. Now we need to find the profit. Cost is given. So we can easily get profit equal to revenue minus cost. This is the revenue, 47,175, minus cost is given 35,000. So we get 12,175. It is important to note that we have put one matrix in row form and another matrix in column forms for the ease of multiplication, so that they become compatible. If A equal to this matrix, then we need to find the value of K such that A square equal to 6A plus Ki, where I is an identity matrix. So first we need to find A square. So we can write A into A, which is 1, 0 minus 1, 5. Then multiply this. 1 into 1 is 1. 1 into 1 is 1. 0 into minus 1 is 0. Similarly, 1 into 0 is 0. 1 into 0 into 5 is 0. So this also will be 0. Now we multiply this row to this column. So minus 1 plus 5. Sorry, minus 1 minus 5 and minus 1 into 0, 5 into 5, 25. So we get A square as 1, 0 minus 6 25. Now we substitute a square into this equation. So let us put a square 10 minus 625, 6 into a. Let us write a as 10 minus 15 plus k into I 1001. This is the identity matrix. Now whenever a scalar is given outside, we have to multiply each element by this number. Similarly here in this matrix, each element has to be multiplied by this number. We will do that. 10 minus 625. This will be 6 and this will be plus k, 6 plus k. This will be 0, this will be 0. This will be minus 6, this will be 30 plus k, so this will be 30 plus k. So we can write here this element being equal 6 plus k equal to 1 or k equal to minus 5. This is the answer. So in this problem we are given two matrices to be equal. We need to find the value of x and y. To get x minus y, we need to get x and y. So we will equate this. Let us equate 3x equal to 12. So 3x equal to 12, x equal to 4. And we will get y from this equation. So y square minus 1 equal to 35. Y square equal to 36. Y equal to plus minus 6. So when we need to find x minus y. So x minus y can be 4 plus 6 or 4 minus 6, which is 10. This is minus 2 and 10. So option B will be the correct answer. The matrix A is a scalar matrix. This is not identity matrix because diagonal elements will be 1. So this is ruled out. This is not a null matrix. There are elements. In null matrix, all the elements are 0. Scalar matrix, the diagonal elements are equal. So this is also not done. Also symmetric matrix, yes. A is equal to A transpose. You can find A transpose. It is same as A itself. So option D is the correct answer. Find the total number of possible matrices of order 3 by 3. So we can write a 3 by matrices as A11, A12, A13, A21, A22, A23, A31, A32, A33. So how many elements are there? Total 9 elements are there in this matrix. And each one can be either root 2 or root 3. So two possibilities are there for each element. So total number of ways will be 2 power 9, which is equal to 512. Option B is correct. If this product is true, then we need to find the matrix A. So how do we proceed? We see that this is number of rows is 3 and columns is 2. So this is 3 by 2 matrix. This is 3 by 1 matrix. So it is multiplying with A. Let matrix size be m into n. So 2 must be equal to m. M must be equal to 2 for matrix compatibility and n must be equal to 1. So matrix A can be written as 2 rows and 1 columns. Let it be U and V. So we need to find U and V. So we will multiply here 3 minus 1, 0, 1, 2 minus 3, uv equal to 2 minus 5 minus 17. So we can easily multiply this 3 into u, that is 3u minus v will be equal to 2. Similarly, this is 0u plus v equal to minus 5, 2u minus 3v equal to minus 17. So if v equal to minus 5, we will substitute here v equal to minus 5. So this will become 3u plus 5 equal to 2, u equal to minus 1 we get. So we got u and v and we can get the matrix A, but here is a catch. We have to check whether this u equal to minus 1 and v equal to minus 5 is satisfied by the third equation. Let us put there. So 2 into minus 1 minus 2 minus 3 into v minus 3 into minus 5 plus 15. This is equal to 13, which is not equal to minus 17. Hence, the matrix A does not exist. In this problem, again, we will first find A square and substitute here. So we can into 3, 6 plus 6 minus 2 minus 2 and minus 3 plus 4. We are multiplying each row with the column. First row with the first column, then first row with the second column, next with the second row and the first column, second row and the second column, element by element, and add it. That's what we are doing here. So we got a square, we substitute here now. So a square is, this will solve 1, 12 minus 4, 1 minus 4 into a, 2, 3 minus 1, 2 plus 7i. 1, 0, 0, 1. We need to show that this is a null matrix. We know that we have to supply or multiply each element here by this number. Similarly, each element here by this scalar. So we'll do that. 1, 12 minus 4, 1. We'll write this as plus. And multiply minus 4 with everyone. So it will be minus 8 minus 12, 4 minus 8, 7, 0, 0, 7. Now we add each element. So it will be 1 minus 8 plus 7, 12 plus 12 plus 0, minus 4 plus 4 plus 0, 1 minus 8 plus 7, this is 0. So this results in a null matrix. That's what we want to prove. If A is this matrix, then we need to find whether A is a skew-symmetric, scalar, diagonal, or square matrix. If it is a skew-symmetric matrix, A transpose will be equal to minus A. A transpose will get the first column as 0, 0, minus 5, but that will not become equal to A. So this is ruled out. It is a scalar matrix. No, scalar matrix all diagonal elements. These are the diagonal elements must be equal, which is not true. This is a diagonal matrix. No, diagonal matrix is this side, not this way. Is it a square matrix? Means all rows and columns are equal. Yes. Option D is correct. Let AB and AB dash and B dash A be defined as matrices A and B. If the order of A is n into m, then the order of B is. This is very interesting question. Now A size is A B dash is being multiplied. So A size is n into m. So for matrix compatibility, B dash must be m into say some r, because this number must match. The number of columns of A must be equal to number of rows of B. So this one equation we got, that matrix B dash is of size m into r, but we need to find r. Again B dash A is compatible, so B dash matrix size is m into r and A is n into m. So for matrix compatibility, R must be equal to n. So R is equal to n. So B dash size will be m into R or m into n. We know that R is equal to n, but we want to find the order of B. So order of B will be n into m. So option B is correct. Sum of two skew-symmetric matrices, we need to find what they are. So let there be two matrices A and B. So A dash equal to minus A and B dash equal to minus B. For skew-symmetric matrices, we want to check their sum. So A plus B transpose equal to A transpose plus B transpose, which is equal to minus A minus B equal to minus A plus B. So A plus B transpose. So the transpose of a matrix is equal to negative of that matrix. So A plus B is a skew-symmetric matrix. So option A is correct. We need to find the value of x. Here three matrices are there. So since a matrix multiplication is associative, we can multiply in any order, means we can multiply these two first or these two first. We'll do these two first so that we get less computation. So let us write this as 1x1 as it is and multiply these two. So 1, 3, 2, this row will be multiplying with this column. So 1 into 1 will be 1 plus 3 into 2 6 plus 2x. Similarly 2 plus 10 plus x, 15 plus 6 plus 2x we get, or this can be written as 1x1 into 7 plus 2x, 12 plus x, 21 plus 2x. So now we know we multiply these matrices. First one will be multiplied by this, then x will be multiplied to this, and 1 will be multiplied to this. We'll do that. So we can write this 7 plus 2x plus x into 12 plus x plus 21 plus 2x, and we expand this, we get x square plus 16x plus 28 equal to 0. We can do using factorization method, x square plus 14x plus 2x plus 28 equal to 0. So we can get x plus 2 x plus 14 equal to 0. This implies either x equal to minus 2 or x equal to minus 14. If A is given this matrix, this is definitely a null, not a null matrix, not a diagonal matrix. Let us see whether it is symmetric or skew symmetric. So A transpose, let us find. A transpose is 0, minus 3, 8, 3, 0, 5, minus 8, minus 5, 0. So this is A transpose. But this is not equal to A. So this is not a symmetric matrix. However, A dash is equal to minus A. This is negative of this matrix itself. So it is a skew symmetric matrix. Now we are given three matrices A, B, C, and we need to find the product. Let us first do BC. So we will multiply this row with this column, element by element, and then add it. Then we do for the next row. So let us do 4 plus 0 plus 4 minus 2 plus 9 plus 16, 0 plus 15 plus 4. Eight, 23 and 9. Now we multiply with A into BC. A into BC. So we multiply 1 minus 1, 0 with 8, 23, 9. This will be equal to 8 minus 23 plus 0 equal to minus 15. This is the product. Not a scalar matrix since diagonal elements are different. This is also not an identity matrix. Let us see whether it is symmetric or skew. A dash we will see minus 1, 0, 0, 0, 3, 0, 0, 0, 5. We see that this is equal to A itself. So A is equal to A transpose. It is a symmetric matrix. If A and B be two matrices of suitable order, then which of these is not correct? We have to find not correct. Now A transpose is A, so this is correct. A complement or A dash plus B dash complement is equal to A dash dash plus B dash dash, so which is equal to A plus B, so this is also correct. KA complement is K outside into A this is also correct. AB complement is equal to, this is not correct because AB complement is equal to B complement A complement. So the correct option is D. If A and B are two square matrices of the same order, then A plus B, A minus B, simple matrix multiplication keeping the order same. So A square minus AB plus BA minus B square. So let us see which one is A square minus AB plus BA minus A. So option A is correct.